Hello students. Today I am going to discuss class 9 science chapter 8 motion. Under this chapter I am going to discuss the equation of motions by graphical method. There are three types of equations of motion. Number 1, velocity time relation, that is v is equal to u plus at. Second one is position time relation, that is s is equal to ut plus half at square. And third one is position velocity relation, that is 2as is equal to v square minus u square. Now we will give the graphical proof of these equations, that is v is equal to uat, s is equal to ut plus half at square, and 2as is equal to v square minus u square. We will prove all these equations separately one by one. So first of all we will look at the first proof of equation, that is equation for velocity time relation, that is v is equal to u plus at. We will prove this. For this we have to draw a graph because we are doing the graphical method of equations of motions. Okay beta, first of all we will draw a graph for it, and graph we will draw is the between the velocity and time. Here we will draw the graph. This is your x-axis, this is your y-axis. On x-axis we will mention the time, and on y-axis we will take velocity. It is SI unit is velocity is meter per second, and time is in second. We take some points on x-axis and some points on y-axis. Okay beta, so let us consider that the first of all object is at point A with initial velocity u. U is the initial velocity of the object. Let after time t the object is reaches at point B with velocity v. V is the final velocity, and finally the object reaches at point B. Okay beta, finally the object reaches at point B. So here v is the final velocity of the object. Okay beta, clear? Initially object is at rest, therefore we will take here u is equal to 0. We will take this point here, u is equal to 0, because initially every object is at rest. Every object starts from rest. Let us consider u is the initial velocity of the object at point A, and then it increases to v. It increases to v at point B in time t. टाइम t के अंदर उस ऑब्जेक्ट की जो वेलोसिटी है वो v इंक्रीज हुई है u to v, and the object is reaches at point B. The velocity is change in velocity, we know that is known as acceleration. Then the velocity change is at a uniform rate, that is a, as shown in figure. Now let us consider, we draw the perpendiculars BC. We draw the perpendicular. First of all I will show you all the mathematical proof of graph. First of all we'll draw this BC. This is the perpendicular on x-axis, that is BC is perpendicular on x-axis, that is the time axis. Okay beta, and from here B point we will draw the perpendicular, that is perpendicular means it makes a hair angle at 90 degree here, and also from here it makes also angle of 90 degree. BE is perpendicular on y-axis, that is velocity axis, and BC is perpendicular to x-axis, that is on the time axis. Clear beta? Velocity axis respect, so that the initial velocity is represented by OA. Okay beta, OA is the initial velocity and the final velocity is represented by BC. Why does BC? Because OE is parallel to BC, so we represent this is final velocity because the at the object is finally reaches at point B, because we take it in final velocity here. Okay, but we mention is here because it is the parallel to each other. Okay, BC parallel to OE. Understand beta? And the time interval is represented by, because it is the time interval. Okay, it is the time is t is equal to 1 second या 2 second. The object is at A, and after second मान लो t is after time interval t is equal to 5 minute या 1 minute, the object is at, so it is the this is the time interval. Okay beta, t1, let us suppose this is t2. Okay beta, so time interval represented by OC into BD. Okay beta, so this is all about the graphical. Okay, now we will prove that. Now we will show his here. Now we'll show here graphical proof of equations for velocity time relation, that is we will prove that V is equal to U plus AT, this relation by this graphical method. Okay beta, so now we will mention here from the given figure we have OA is equal to U, that is initial velocity, that is initial velocity of the object. Okay beta, and BC you can write it as OE is equal to BC is equal to V, that is the final velocity of the object. Understand beta? And one more quantity we have the time. Okay, the time interval, that is T, is represented by OC into BD is equal to BC minus CD. Okay, it is equal to T, you can say that OC, only you can say that OC is equal to time T. Okay beta, because here is OC, this is the time. Okay, at time T the object is reaches at point B, OC is equal to T. Now what will we do here, we will draw AD. Look at here, AD parallel to OC. Understand beta? AD parallel to OC. Okay beta, so let us draw AD parallel to OC. Okay, and from graph we observe that what we will observe, BC, this complete BC is equal to BD, this part BD plus CD. Okay beta, you understand? This complete BC, it is the sum of two terms BD plus CD. Okay beta, so BC is equal to BD plus DC. In case, look at here beta, from this part AOCD, if AD is parallel to OC and AO is parallel to DC, these are parallel and equal. Okay beta, OA is equal to CD and AD is equal to OC. So we can write what we can write in place of DC, we can write OA, because plus OA. You can give reason here, because DC is equal to OA. Okay beta. So what we will mention here above BC. What is the value of BC? What is the value of BC? That is V. Okay beta. And what is the value of OA? That is the U. Okay, put these values here. V is equal to BD plus U. So we will calculate the value BD from here. BD, U is plus here. When it comes on left hand side, it will become minus. So this is our values of BD. Okay, put it name here 1. Also we know that from the definition of acceleration, what we know, acceleration is velocity, change in velocity. What is acceleration? Change in velocity upon time. What is acceleration? Change in velocity. Change in velocity means final velocity minus initial velocity upon time. That is AD is A is equal to, so where we will see the change in velocity. Change in velocity is part here BD, because the velocity changes from point here to here. If here is it is U, so here is also U. Here is also U. It is point V, so here is also V. So change in velocity final minus initial, that is V minus U. That is the change in velocity, that is the BD. Okay beta. So what will be here? BD upon change in velocity upon time. Change in velocity upon time. Look at here, change in velocity upon time. Okay beta. So what is the time here? OC. OC. Okay. BD upon, this is time, AD. तो AD किसके बराबर है? OC के. ओके बेटा, तो वी कैन राइट इट हेयर BD by AD, that is BD upon OC. ओके बेटा, तो A is equal to, what is BD? So we will find the value of BD. What is OC? OC is here. Look at here. What is OC? OC is T. Look at here. OC is T. So what we'll find? We will the cross multiplying here. So we will get the value of BD. ठीक है, तो put the value of BD. Put the value of BD in equation 1. What is our equation 1? Our equation is here. BD is equal to V minus U. This is our equation 1. So we will put the value of BD which we calculated now in equation 1. That is, what is the equation? BD is equal to V minus U. So what we can write here? BD, what is the value of BD? 80. 80 is equal to V minus U. So we will take it here. ठीक है, U on the left hand side and V on the same here. So what we calculate? 80 plus U is equal to V, because if any number on the right hand side with the opposite sign, when it comes to the another side, the sign will change. If U is here negative, then it on coming on the left hand side, it becomes positive. So we can write it at V is equal to U plus 80. This is the relation which we have to prove graphically. hence proved. Okay beta, what will we be doing here? Velocity, graphically proof of the equation of velocity time relation, that is we have to prove that v is equal to u plus at, but we have to prove it by the graphical method. Okay, so we have to first of draw this graph is between velocity and time. Okay, okay beta, the OA is the initial velocity of the object, OE is equal to final, that is the BC, because OE is parallel to BC, it is the V is the final velocity of the object, that initially at the object is at A and final object is at point B, and after the time interval t. So we take these values here. OA is equal to u, this is the initial velocity, OE is equal to BC is equal to V, that is the final velocity. Let OC is equal to t, this is the time interval, the time at which the object reaches at point B. So for this let us draw AD parallel to OC. Okay, we will draw AD, this AD parallel to OC, and from this graph what we observe that BC, because this is the final velocity. Okay, so we need all the three quantities V, U, A and T. Okay, BC, what is the BC? BC is the sum of two numbers BD and CD. CD you can write it CD or DC, both are same. So therefore it is the BC is equal to BD plus DC, BC is equal to BD plus OA. Why it is OA? Because this is equal to OA. Okay beta, because look at here, DC is equal to, if you put the pen here, DC is equal to OA, because both are equal and parallel to each other. Okay beta, so we write it DC is equal to OA. So we have all the values of here. BC is equal to V from above equation, this one, BC is equal to V, OA is equal to U, and OC is equal to T. We have all the values. So put the values. V, BC is equal to V here, okay beta, and OA is equal to U here. From here we will calculate the value of BD by replacing the U on the left hand side. It is plus here, coming on the left hand side it becomes negative. So BD is equal to V. This is the change in velocity, and change in velocity is known as acceleration. So A is equal to BD by AD, BD by OC. This is A is equal to cross multiplying AT. Put these values here, we will get the relation. This is the relation for proof for velocity time relation. Okay beta, have a nice day.